Hi there! Welcome to the Math Skills series on Jetpack DataStore, a data storage replacement for shared preferences. Let's see how DataStore works, what implementations it provides, and their individual use cases. We'll also look at what benefits and improvements it brings over shared preferences and why these make DataStore worth your while. DataStore is a Jetpack library that provides a safe and consistent way to store small amounts of data, such as preferences or application state. Based on Kotlin coroutines and Flow, which enable asynchronous data storage. It aims to replace shared preferences, as it is thread-safe and non-blocking. It provides two different implementations, Proto DataStore, which stores typed objects backed by protocol buffers, and Preferences DataStore, which stores key value pairs. Most likely you've used shared preferences in your apps. It is also likely that you've experienced issues with shared preferences that are hard to reproduce. Seeing out crashes in your analytics due to uncaught exceptions, blocking the UI thread when making calls, or inconsistent persisted data throughout your app. DataStore was built to address all of these issues. Let's take a look at a direct comparison between shared preferences and DataStore. With most data storage APIs, you often need to get notified asynchronously when data has been modified. Shared Preferences does offer some async support, but only for getting updates on changed values via its listener. However, this callback is still invoked on the main thread. Similarly, if you wanted to offload your file-saving work to background, you could use Shared Preferences apply, but keep in mind that this will block the UI thread on fsync, potentially causing jank and ANRs. This could happen anytime a service starts or stops, or an activity pauses or stops. In comparison, DataStore provides a fully asynchronous API for retrieving and saving data using the power of Kotlin coroutines and Flow, while reducing the risk of blocking your UI thread. For those unfamiliar with Kotlin flows, this is just a stream of values that can be computed asynchronously. Shared Preferences API supports synchronous work out of the box. However, its synchronous commit function for modifying persisted data may appear safe to call on the UI thread, but it does in fact perform heavier I/O operations. This is a risky scenario that could and often does lead to ANRs and UI jank. To prevent this, DataStore doesn't offer ready-to-use synchronous support. DataStore saves the preferences in a file and under the hood performs all data operations in the background, unless specified otherwise, keeping your UI thread unblocked. However, it is possible to combine DataStore and synchronous work with a bit of help from coroutine builders, as we'll see later. Shared preferences can throw parsing errors as runtime exceptions, leaving your app vulnerable to crashes. For example, the class cast exception is a commonly occurring exception thrown by the API when the wrong data type is requested. DataStore provides a way of catching any exception coming your way when reading or writing data, by relying on Flow's error signaling mechanism. Using map key value pairs for saving and retrieving data doesn't offer type safety protection. However, with the Proto DataStore, you can predefine a schema for your data model, get the additional benefit of full type safety. Shared Preferences doesn't guarantee data consistency in a multi-threaded environment. This means you cannot rely on your data modifications being reflected always and everywhere. This can be dangerous, especially since the whole point of this API is persisted data storage. In comparison, DataStore's fully transactional API provides strong consistency guarantees, as the data is updated in an atomic read, modify, write operation. It also provides read after write consistency, reflecting the fact that all updates that have completed will be reflected in read values. Shared Preferences doesn't have a built-in migration mechanism. It is up to you to do some tedious, error-prone remapping of your values from your old storage to the new one, and then some cleaning up as well. All this increases the chances of runtime exceptions, as you could easily run into issues with data type mismatch. DataStore, however, provides a way of easily migrating data along with the provided implementation for Shared Preferences to DataStore migration. Now that we've seen what benefits DataStore offers over Shared Preferences, let's talk a bit about how to make a choice between its two implementations, Preferences and Proto DataStore. When it comes to data structuring, Preferences DataStore reads and writes data based on key value pairs without defining the schema upfront. Proto DataStore, however, uses protocol buffers for added readability. Using key value pairs allows a quick migration with minimal changes from Shared Preferences into Preferences DataStore. Proto DataStore, on the other hand, enables you to work with more complex data, such as enums or lists. Finally, if you don't require full type safety with your data storage, then you could choose Preferences DataStore. However, if you do need this kind of support, then Proto DataStore is the better option for you. You might ask, well, why not just use Room to store my data? And that's a fair question. So let's see where Room fits in all this. We start by asking, do we need to work with small and simple datasets? The answer is no. Then it means you're required to work with larger and more complex datasets. This type of data tends to require partial updates and referential integrity between different data tables. If all this is true for your app, you should consider using Room. However, if you're working with small and simple datasets like preferences and app states, it is likely you won't need partial updates or referential integrity. This matches your requirements. You should go with DataStore. Right, in this episode, we've gone into more detail on DataStore, how it works, the changes and improvements it brings, and how to decide between its two implementations. In the next 2 episodes, we will further discuss Proto and Preferences DataStore, how to read and write data, handle any errors, and how to migrate from shared preferences. So hit subscribe and stay tuned.